Hi friends, welcome to my channel Math Mantra. Today I am going to discuss with you yet another topic in statistics. I hope you have watched my first class of basic concepts in statistics. Our today's topic is measures of central tendency. I welcome all my dears to the session. Let's begin. Let's start with the definition of measures of central tendency. It is a statistical measure or a single value which represent the center point of a data set. To be more precise, this measure gives us an information regarding the tendency of the data set to cluster at the center of the observations. That is why it is called measures of central tendency. Hope the definition is clear to all. Now let us consider what are the different types of measures of central tendency. Basically, there are three forms: mean, median and mode. So we'll start with mean. When we consider mean, there are again three forms. First one, arithmetic mean. Second, geometric mean. Third is harmonic mean. So let's go into the details in terms of definition and problem solving. So consider the first one, which is arithmetic mean. Now, arithmetic mean is nothing but the normal average that we usually consider in all contexts. Say for example, average height of students or average age of students or average salary of employees. In all these cases, the average that we are taking is arithmetic mean of those observations. And all of you will be knowing the formula to find arithmetic mean will be sum of the observations divided by number of observations. So in statistical term, when we consider the average, that is arithmetic mean, if we have n observations, x1, x2, etc., xn, then average, which is denoted by x bar, that is the notation which is used to represent average of the set of n observations, which is given by x1 plus x2 plus etc. up to xn divided by n. So using this formula, we can find the arithmetic mean of the given data set. Hope the definition of arithmetic mean is clear to you. Now, there are some special cases in which arithmetic mean can be found out without going for all the additions as explained above. So let me explain you those cases. Here, see the example. The observations are 25, 30, 35, 40, 45. It's very clearly seen that the successive terms are having a difference of 5 here. So such a data we said to be in arithmetic progression. When there is a constant difference between the successive terms, then the sequence that we have or the data that we have is said to be in arithmetic progression. So if the sequence is in progression like this, we need not add up these observations in order to find our arithmetic mean. We can get it just by considering the central value or central observation. So here, when there are n observations, in this particular case n is 5, there will be exactly one observation which comes in the middle, which is 35. That will be the arithmetic mean of this data. Hope it is clear to you. In the same manner, if the given data has got even number of observations, we can similarly find out the average without going for addition. So take another example. 37, 39, 41, 43, 45, 47. In this sequence, we can see For this data, there are 6 observations. So it is very evident that again there will be 2 observations which is coming in the middlemost positions. What are they? 41 and 43. So what you need to do is we have to just take the average of 41 and 43, which is the arithmetic mean of 41 and 43, which all of us know it will be 42. So for this entire data, average will be 42. So for these 2 examples, since both of them satisfy arithmetic progression, since there is a constant difference between the successive terms in this data, we can find out the average without going for much calculations. So this specific cases we can always consider in terms of statistical measurement. So when we consider the generalization, when the data is odd, when n is odd, and if it is satisfying arithmetic progression, then mean gives you the n plus 1 by 2th observation. That means the observation which comes in the position, this is indicating the position of the observation. N plus 1 by 2th observation gives you the mean. Similarly, when n is even, then we have to find out the average of, there will be 2 middlemost observations, n by 2th observation and n by 2 plus 1th observation. So need to get the average of those 2 values to end up with the arithmetic mean of such a data. So this is how we have to find out the average, which is the arithmetic mean of given data. Now let us pass on to geometric mean. How do we calculate geometric mean for a given data? Now, first of all, let me explain you the general formula. Suppose again we have n set of observations, x1, x2, etc., xn. The formula is given by nth root of product of the observations. And it is written by x1 into x2, etc. up to xn whole to the power 1 by n. Now, here also, as I have discussed in the previous case, we have got a similar application for certain data. So here, take an example. If we have 5, 10, 20. Look at this series. Only 3 observations are given here. When we consider the ratio of successive terms, we are getting a constant here. Or in another way, we can say, if we multiply each term with a constant, we are getting the successive terms. 5, when you multiply with 2, you are getting 10. 10 multiplied by 2, you get 20. So, if all the terms we are getting by multiplying the same constant throughout, then such a data is said to be in, again, progression. This is called geometric progression. So, if the given data that we have satisfy geometric progression, then again, geometric mean will be the middlemost observation. So, we need not have to simplify using the formula to get the answer. We can directly go with the middlemost observation. Now, I have explained here how to go for it if it is not in geometric progression. So, when we consider the same data, if it is not in geometric progression, what we need to do is we have 3 numbers here or 3 observations given. As per our formula, what we have to do is we have to multiply the terms whole to the power 1 by 3, or we can say that cube root of product of these numbers. So when we consider geometric mean, always remember, don't multiply the numbers, because once you multiply the numbers, it will become very big number to take the cube root or any root of that such number. It's not going to be easy. So always choose factorization. So simplify the terms in terms of smaller factors, and what you get here is 2 is repeating 3 times and 5 is also repeating 3 times. Simplifying, we get it as 2 cube into 5 cube whole to the power 1 by 3. So both power 3 and 1 by 3 cancels. You are ending up with the answer 10. Now look at the question. 5, 10, 20, as I have already told you, if there are 3 terms, what will be the geometric mean? It will be the middlemost observation. So we are getting 10 here. So without doing any of this calculations that I have just explained, we can directly go for the answer. Now, if the data doesn't satisfy geometric progression, then you have to follow the steps which I have explained now. In the same manner, if you have even number of terms, in the given data, if it is satisfying a geometric progression, we can find out geometric mean by considering the geometric mean of the middlemost observations. So geometric mean of middlemost observations means you have to take only two middle numbers there, and geometric mean of those two numbers means, suppose if it is two numbers AB which comes in the middlemost position, then its geometric mean means square root of A into B. Why square root? Because there are only two terms. So it gives you square root. So likewise we can find the geometric mean of such a data. Hope the definition and how to solve problem to find the geometric mean of data is clear to you. Now let us consider the next mean, which is harmonic mean. Now before going to the formula, let me explain you what is harmonic progression. When we consider the n set of observations x1, x2, etc., xn, we say that these observations are in harmonic progression only if their reciprocal sequence satisfy arithmetic progression. I have already explained what is arithmetic progression. So this is how we define a progression to be in harmonic form. Now, harmonic mean is given by n by 1 by x1 plus 1 by x2 plus etc. 1 by xn. So from this formula it is very clear why we are getting a formula in this particular manner. So since the reciprocal sequence satisfy the corresponding arithmetic progression, we are finding the average for that data and finally we are taking the reciprocal so as to arrive at harmonic mean. Hope the formula is clear to you. Now let us see one example based on this. Harmonic mean of 2, 3, 5 and 6. So here we have 4 observations given. So n is 4. Now using the above formula, we can use 4 by 1 by 2 plus 1 by 3 plus 1 by 5 plus 1 by 6. For the denominator, all our fractions, we need to use the LCM here. So what you are getting here is, by using LCM, which is 30 for the numbers 2, 3, 5 and 6, simplifying, we get 4 by 36 by 30, which is 10 by 3. So harmonic mean for this data consisting of 4 numbers will be 10 by 3. Now let us consider the next measure of central tendency, which is median. Median represent the middlemost observation when the values are arranged in order of their magnitude, ascending or descending order. Now consider how to find the median of a data. Here again there are two possibilities. The data can contain odd number of observations or even number of observations. As discussed in the case of arithmetic mean, the process is same. The first step is arrange the data in order and then we have to check for the middlemost observation. So let us explain this in terms of examples. Now, when n is equal to 5, take an example 23, 39, 45, 85 and 92. So here I have given 5 observations. Already it is arranged in ascending order. So what will be the median of this data? It will be the middlemost observation, which is 45 coming. So in this case median will be 45. Now see another example 23, 25, 27, 28, 30, 35. For this data there are 6 observations and also arranged in order. It's already in ascending order. If not, you have to write the data in ascending order or in descending order. Any one order we have to arrange the data before we find the median of the data. Now here since there are 6 terms or 6 numbers, we have 2 middlemost observations. So median will be the average of the middle 2 observations. So here middle 2 observations are 27 and 28. It's average. Average means arithmetic mean. So you have to find the arithmetic mean of 27 and 28, which you get as 27.5. So for this data, median will be 27.5. So this is how we have to find median of a data when it has odd or even number of terms. Now from this both explanation, it will be clear to you if the data is in arithmetic progression, its arithmetic mean as well as median will be always the same. Now let us pass on to the last measure of central tendency, which is mode. Now mode of a data is the observation which is most repeated in the data, or we can say the observation whose frequency is maximum. Now take an example. Look at the series. I have given you a set of numbers. Here many numbers are repeating. 1 is repeating, 2 is repeating, 3 is repeating. So what you have to do is identify which observation is repeated maximum. So from this we can see 2 is the observation which is repeated 6 times. So for this data, mode will be 2. Hope to find the mode is clear to you. Now there are some special cases for mode. As we have seen the other measures of central tendency, for all those measures, we have a unique answer. But in the case of mode, we can have more than one answers. Now, if in a series, say for example, look at the series 2, 4, 4, 5, 6, 7. So for this data, you can see number 4 is repeated 2 times. So for this data, mode will be 4. It's very clear. Now, consider another example. 2, 3, 5, 15, 20, 21, 5, 3. Now, here we can see 3 as well as 5 are equally repeated 2 times. 3 is repeated 2 times, 5 is also repeated 2 times. So, what we can conclude here, we have 2 modes here. So, for this data, there are 2 modes. The previous data, we have only 1 mode. So, generalizing, the given data can have 1 mode, 2 mode, 3 modes, or more than any number of times any observation being repeated equally, then all those values will represent mode of the data. So, what we can say is, if the data has 1 mode, we call it as unimodal data. If it has 2 modes, then it is said to be bimodal data. 3 modes is trimodal data. If it is more than 3, starting from 4 onwards, any number of times a particular set of repetitions of the observations are seen equally, then it is said to be a multimodal data. Also, a data can have no mode. That means if there is no observation which is having more than 1 frequency, that is all observations are there only once, then such a data we say that it has no mode and we call it as ill model data. So this is a set of specific characteristics which is satisfied only by mode of a given data. So these are the different measures of central tendencies that we have discussed today.
That's all for today's class. Hope you enjoyed the class. Send your feedback and comments in the comment box. See you soon with another concept in statistics. Thank you.